This video is a continuation of the previous one when we were talking about structures and pointers to structures. So we had just finished up using the pointer notation and the existing functions that we had to enter data and to print data. Now, in the sample program, I have a couple of lines here that are to be used to enter data by value for Alice and then would print those out. But we just did that for Bob, so I don't think we're going to do it for Alice again. I want to move down a little bit further and make a brand new variable of type student record, which I'm just going to call student. So let's declare that. We'll have a student record, and it'll be a pointer to student. Yeah, okay. I guess Visual Studio automatically puts the asterisk over there, so I'll let it do it the way it wants to. Alrighty, and to finish this up, let's go ahead and make a new student record here. And that will generate a brand new equal sign there. So this will declare a pointer, and it will also ask the operating system to provide the space for that structure, and it returns the address, saving it in our pointer to the student. Now, this says we will call enter data by reference to initialize the pointer student, which we will do shortly. But before we call the that function, let's look at how we can populate some of these fields, these members of the student record right here. How do we do that with a pointer? Now, we had our pointer to Bob up here. We had the pointer to Alice further up, but we dereferenced the pointer and sent essentially ordinary Bob and Alice into these functions, and the function operated the same as it did for the non-pointer types. But let's see how we can utilize this pointer to a student to initialize all of those members, the name, first name, last name, homework, and all that. How do you write that? Okay, well, if we did pointer student dot first name, which you might think would be a good option, is equal to Mary, then Visual Studio is trying to help us out, so it put this funny thing in there, but let's see if I can convince it not to do that. So if we only had the dot, then it will not work. Visual Studio corrected it, but I don't want it to correct it just yet. This is what you would think possibly that we should do. Just use the dot notation like we did before. But the thing is, this is a pointer. Well, okay then, if it's a pointer, then how about I dereference the pointer here? Is that going to help? And let me emphasize that this is a very, very important thing to remember. And it's if you don't grasp everything to begin with, then make sure you look over this a couple of times or more. Rewind it and look over it as many times as you need to understand what's going on here. So I declared this pointer, and now I'm trying to use it to populate these members of the structure. I tried the dot here. No, that didn't work. Okay, I tried to dereference the pointer. That doesn't work either. The reason it doesn't work is that at this point, it is not understood whether this part is a pointer or is that member a pointer. A member can be a pointer also, and we'll get to that. But this is ambiguous. This is an ambiguous statement. We can make it unambiguous by using parentheses. So if I put a parentheses here and here, then this tells the compiler that, well, I need to put the star on the inside. Now, this tells the compiler that this thing is the pointer. So you dereference the pointer, and then you take the particular member of the structure that you're interested in. So if you have a pointer to a student record and you want to populate the various members, this is the syntax that you have to use. So let's proceed with this, and then I'll come back and show you a shorthand for that. I will copy and paste this part to save some typing, and you can see that everything pops up the way it normally would. So let's just put some values in here to populate this particular student record. Oh, it'll take a little while. So birth date dot month is equal to August. Okay, birth date dot day is equal to the 18th. And birth date year is equal to 1997. And we'll keep going. Let's see, grade point average, I think, comes up next. Then we can do the exam average. And the next member would be the homework average. And that's about it. I don't want to use the compute grade just yet because that would we have to call a function to do that. And we don't know how to call a function right now with this thing. Actually, it would be okay, I guess. No, I'll wait. I don't want to complicate this more than it is already complicated. So this works. This is the syntax, very important syntax for you to remember. All right. Now, this is all filled in. So let's call our print record. I guess it's the same thing. You know, if we're calling print record or compute grade, it's really going to be the same type of thing. We have to call a function for that. So let's go ahead and do the compute grade. And compute grade is just expecting a regular student. So we do need to dereference this. And I have to spell it correctly. And now let's print out the data. And skip a couple of lines in between. And we'll call print record. And again, it's just like we did with the pointers up above for Alice and Bob. We just dereference our student, our pointer to a student. Semicolon. And let's stop it right there. Let's drop another system pause right there. Lots of new stuff. We declared a pointer to a student, which is a pointer to a student record. And we used our new function to dynamically generate the storage. We used this syntax to populate all the members. We computed the grade. We print out the data. So let's run our program and see what we get from this. All right, now it's compiled. So we do have to go through the first parts of the program and type in the data for Alice and Bob. So bear with me while I do that. Grade point average, exam average, homework average, compute the grade for Alice, and print out the results. Here was the system pause, and then we'll do the same information for Bob. Date of birth, grade point average, exam average, homework average, and then we get that grade. So that takes care of Bob. Now, this was the data we just entered for Mary. So you can see here that we created the dynamic record, we used a pointer, and using this notation, we filled up all of Mary Wilson's information. So it works. I've shown you that it works, and this is the syntax that we're using. We did just dereference the pointer as we did with the pointer to Bob and the pointer to Alice to call print record to print out the data. And that's how we got this information. Now, that's good. So all that works. Let's stop this program. And let's call enter data by reference to initialize our pointer student. Right? So in this case, we did fill up the data. And in fact, I don't really need to do this. I don't think call enter data by reference to initialize pointer student, because I have shown you that you can also dereference this pointer and send it to a function, compute grade in this case, print record in this case. And if we wanted to call our enter data by reference, we could call it in exactly the same way we did up here with pointer Bob and previously for pointer Alice. So that same syntax works. Well, then what do we do here? Let's look at an alternate way that we can use to fill up the data. I'm going to go back up here and let's look at all this again. It turns out that there's a shorthand notation that we can use to replace this type of notation. So I'm just going to edit this record to show you what that is. And it is the same thing that Visual Studio was trying to do for us earlier. Okay, I'm going to replace this with a dash and a greater sign. And I'll take off this. Now, this works. So this notation is what is normally used in C and C++ when you're dealing with pointers and structures. So this is called the little arrow notation. And you can see it's exactly equivalent to using the parentheses, the asterisk, and the dot. This is what you want to use. This is what professional programmers would use, and you want to be a professional programmer. All right, so without taking a lot of extra time, let's just go through and let's alternate, let's swap out this notation. So I think that's probably the quickest way that we can go about this. I'll come back and repair this in just a few seconds. So it's called the little arrow notation. And I'm deleting it, this extra parentheses and asterisk. Okay, so let's make just a little comment here. So I left off the greater than sign. So this is the technique, and this is the fun stuff. So if you have a pointer to a structure and you need to access some of the elements, the members of that structure, this is the notation to use. Now, let's go down and let's add a function. And this new function is going to be a function that we use to pass in a pointer. So how do we pass a pointer into a function and change that function to, in this case, we're going to just use it to enter data. So we're entering data by reference. So let's just make a copy of this one that we already have that does not use pointers. So I will make a copy of that. And since we're at the end of our main program, let's just paste it in right here. Now, what I want to do is, instead of just having an ordinary student record called student here, is I want to make that a pointer to a student record. So now this function is expecting a pointer to a student record. Right now, and let's also name this something different so it's not confused with our other program. We don't really have to do much to the rest of this. You can see all the red lines, and I can show you that if you use the parentheses, the asterisk here, and the parentheses here, then the red line goes away. So that notation we saw earlier works, but now we know there's a better way. So we can use the little arrow notation. So if we want to pass a pointer to a student record into a function and use that pointer, we just need to change the dot to the little arrow. So everywhere we see that, we will need to replace it with our little arrow. So bear with me while I make those changes. So you can see we'll go down the list, exam, homework. And now we've replaced that with a little arrow notation everywhere. At the bottom, since this is a call by reference, notice the what happened here was we no longer have the ampersand. I'm sorry, this is entered data by value. Sorry. So never mind. We never had the ampersand to begin with. This is entered data by value. But how do we return this? Well, this we're passing in a pointer to a student, and we want to return the student record. Well, if we want to do that, we have to dereference it. So look carefully then at the way I have written this new function, and this allows us to pass in a pointer to this enter data by value function, and that's just an alternate way that you can call the function. And it also shows you the little arrow notation that you can use in here. Well, given this new function, let's try it out. So let's take this, let's copy the first line, and let's make a prototype. Where are the prototypes? Okay, here they are. So we have that. And when we get down here past all of this stuff, we say call enter data by reference. So let's change that because I used the value instead. Call enter data by value underscore pointer to initialize pointer student. Okay, now this call is going to essentially wipe out the data that we had here. We're going to enter new data for a different student. We've recorded Mary's data and we have printed it out. So now we'll just use the pointer for another student. Well then, to do this, we want to pass the pointer into the function. Let's enter the line here. Well, we know we need to call enter data by value pointer. And this time, this function is expecting a pointer to a student. Well, I have one of those, like that, pointer student. But it turns out this is a call by value. Therefore, I need to have an assignment statement that will collect the data when it comes back. Let's scroll down to that function again, and we notice it dereferences student. Okay, there's the pointer. We dereference it, so it returns an ordinary student type. So the thing that I have to have when I capture it is not this. That is not correct because pointer student is not what's returned. The thing that's returned is a dereferenced pointer. Therefore, I need to dereference this because this is a pointer to a student and it returns just an ordinary student. You dereference this pointer, so it returns a regular student. That works. So here is an example where I am using a pointer inside a function. And here is the syntax. We have student, pointer to a student record. Inside, we just changed the notation to use the little arrow notation for all of these cases. And when it returns, it's dereferencing the pointer to send back a regular student type, not a pointer to a student. We could have chosen to return a pointer up here if we wanted to, but I don't want to go into that just yet. Given all that, let's compile the program and let's run it. And one more thing, let's print out the data record for that student. So this is the same thing as before. So let me just copy and paste it right here. And let's put this end line right up above that to separate things a little bit. Okay, now what I'm going to do is to pause the video. Let me build it first to show you it works. I'm going to pause the video. I'm going to enter the data for Bob and Alice up here so you don't have to see me do that all over again. And then I'll start the video again and we'll see what happens here for this particular call to this function. Now I will resume the video. Thanks for waiting. And somewhere I have the output. So I've entered the data for Bob and Alice, so we don't need to see that again. Here's the data for Mary Wilson that was produced up here. Now I am going to call enter data by value pointer and initialize pointer student with some different data. So let's bring this back up. And you can see here we've called enter data by value pointer to initialize pointer student. All right, well, let's just enter some data for a different student. Doesn't matter. First and last name, date of birth. Let's do 9/18/2000. Grade point average. Let's do 2.9. Exam average 89. Homework average 87. Here is the data record for Roger Simmons. We have printed it out from the print record or the print record function. You can see all the data is there. And this terminates the program. Thus, here is an example where we have made a function that accepts a pointer type. Here is that function. Be sure that you understand all this. Well, that's quite a bit. There's a lot going on in this video with pointers and functions, well, pointers, functions, and structures. And the big thing is our little arrow notation. That's very, very important. All right, I think that's enough for this video. We'll stop here and then we'll pick up later with yet some more information about structures and pointers.